In a math course that I teach, students are given a question that I refer to as the geometry proof. They are given a polygon on a coordinate plane with the coordinates of the vertices, and they are asked to prove that it is a certain geometrical shape. In this video, we're talking about the different types of triangle. In a geometry proof, you will be given a coordinate plane with the triangle drawn on it, with the coordinates of the vertices, and you will be asked to prove, for example, that it is a scalene triangle, or prove that it is an equilateral triangle. For my example, I'm not going to do the calculations, so I have not given real values for my coordinates. I'm just using letters to designate the coordinates. To prove that a triangle is scalene, in a different context, you might have to first prove that it is a triangle, that it has three sides, and that it is closed. But not in this context. In this context, you can see with what is given that it is a triangle and it is a closed polygon. So all we have to prove that this triangle is scalene. To prove that a triangle is scalene, we have to prove that it has three sides of three different lengths. And how do we prove that? We prove it by using the distance formula. You will have to use the distance formula 3 times, 1 time for each of the 3 sides of the triangle. You will have to get 3 different values for the measures. And to justify it, you have to say that a scalene triangle has 3 sides of 3 different lengths, and you have to say that you are using the distance formula to prove that. If we are asked to do the same sort of proof but with an equilateral triangle, we are proving that it has 3 congruent sides and again, we are doing that by using the distance formula. So do your distance formula 3 times, get the same value for all 3 measures, and then say that an equilateral triangle has 3 congruent sides, and say that you are using the distance formula to prove it. An isosceles triangle has 2 congruent sides. And again, we are using the distance formula to prove that. It is enough to prove that 2 sides are equal in length. So if the first 2 sides that we do the distance formula to are giving the same value and therefore are equal in length, at that point we can stop. But we have to justify what we are doing by saying an isosceles triangle has 2 congruent sides and saying that we are using the distance formula to prove that. Finally, we have the right triangle. This is the only one that's a little bit different. We have to prove that a right triangle has an internal 90-degree angle. And we are going to do that using the slope formula. So you find the 2 sides in the diagram that you think are perpendicular to each other. You do the slope formula to both of those 2 sides using the coordinates of the vertices that are given. And then you have to prove that the 2 slopes are perpendicular or represent 2 perpendicular lines by showing that the 2 slopes are negative reciprocals of each other. So for your proof, you have to say a right triangle has a 90-degree internal angle. You have to say you are using the slope formula, and you have to say that the slopes of 2 perpendicular lines are negative reciprocals. This is how we use slope formula, distance formula to prove what type of triangle we were given on a coordinate plane.